Hi guys, welcome back to Physics Form 4 KSSM. So today we are going to discuss Chapter 4 Heat. So the first topic in this chapter is 4.1 Understanding Thermal Equilibrium. Let's get started. So in this topic, we are going to discuss about what is heat, what is temperature. Is there any relationship between heat and temperature? Okay, heat is a form of energy. An object becomes hot when it absorbs heat. Heat is measured in joules, capital J. One source of heat is like a flame or sun. Sun is the most biggest source of heat. Okay? Temperature measures how hot or cold an object is. The unit of temperature is degrees Celsius or Kelvin. The SI unit we use is Kelvin. Temperature can be measured with a thermometer. Heat and temperature are different. The table below shows the differences between heat and temperature. So you must be able to differentiate between heat and temperature. So from here we already get one idea that heat is a form of energy and temperature is a degree of hotness of an object. Okay, now look at the differences between heat and temperature. Okay, heat is a form of energy, but temperature, the degree of hotness or coldness of a body. Heat can do work, but temperature cannot do work. Heat is measured in joule, and temperature is measured in degrees Celsius or Kelvin. Heat transferred from a hot area to a cold area, or from hot object to cold object, and also at the same time from cold to hot also at slower rate. Okay? Temperature increases when heated and decreases when cool. So these are the differences between heat and temperature. Okay, now the common mistake made by some of the students. Common mistake, object with the same temperature contain same amount of heat. The higher the temperature of the object, the larger the amount of heat contained in it. Is it true or not? Okay, so the truth is the amount of heat contained in an object depends on the type of material that the object is made of, the mass of the size of the objects, and of course the temperature of the object. So we need to take into account these three factors in order to determine whether the object has higher amount of heat contained in it or not. Okay. Okay, now we want to look at if we have one object A and one object B. So object A is a hot object, object B is a cold object. Now what we do, we let A and B in thermal contact. What is the meaning of thermal contact? Thermal contact means there is heat transfer between the two objects. So you know that maybe you have studied in science before. Heat can be transferred in three ways. It's like conduction, convection, and radiation. So now thermal contact means heat can be transferred between the two objects. So let's look at what happened. Okay, the red color one is the hot object. The blue color is the cold object. So you can see for hot object it will transfer heat at higher rate. Okay, so heat will be transferred from hot to cold at faster rate or higher rate. Okay, so you can see the bigger arrow here, the red color arrow. And then from cold to hot, there's also heat transfer, but at a very slower rate. So you can see the blue arrow is smaller compared to the red arrow. Okay, so don't say that there's no energy transferred from cold to hot. There's always heat transfer between the two objects, but from hot to cold at higher rate, from cold to hot at slower rate. Okay, now after some time, we let the two objects in thermal contact, what happened? Finally, the energy transferred, okay, between the two objects become equal. So you can see the size of arrow now becomes same size. So energy transferred at the same rate between hot and cold. Okay, so we can say there's no net heat transfer between the two objects. It become equal already. From A to B equal to B to A. So the rate of heat transferred become equal. So we can say no net rate of heat transferred between the two objects. So when this situation achieved, we can say thermal equilibrium is achieved. So what is thermal equilibrium? The two objects finally have same temperature and at the same time no net flow of heat between the two objects. Or we can say no net rate of flow of heat between the two objects. Okay? Or in other words, we also can say that the flow of heat between the two objects become equal. Okay? Okay, now you can refer to your textbook on page 120. That's activity 4.1 to show thermal equilibrium between two bodies in thermal contact. So apparatus needed, 2 retort stands, you can see from the diagram, 2 thermometers, 250 milliliter beaker label A, 50 milliliter beaker label B, measuring cylinder and stopwatch. Materials that needed, 50 degrees Celsius of hot water, tap water and tissue paper. So you can look at the arrangement here. So at first what we do, we have 2 beakers here. One is 250 milliliter, one is 50 milliliter. So what we do, we fill the 50 milliliter with hot water, 50 degrees Celsius. And the bigger one, 250 milliliter, we fill with tap water. Okay, so you can place a thermometer into both of the beakers. Now what we do, we put the beaker with hot water into the beaker with tap water and then measure the temperature. Okay, so what we do, record reading of both of the thermometers every 30 seconds until the reading of thermometers are equal. Meaning equal means there's no increase in temperature. It's become like constant reading. Okay, so this one will end about 5 minutes. So what we do, finally when the two thermometers show same reading, we can conclude that thermal equilibrium is achieved between tap water and the hot water. So it becomes same temperature. So there is a thermal contact, there will be flow of heat between tap water and hot water. So after some time, thermal equilibrium will be achieved, there is temperature become equal, no net flow of heat between the two tap water and hot water. So this is activity to show thermal equilibrium between two bodies in thermal contact. Okay, now when we want to measure temperature, we use thermometer. So the thermometer that we use in the lab, normally we call it liquid in glass thermometer. So you can see there's a bulb here, this is a bulb, and a capillary tube. So inside the bulb and capillary tube, you can see there's a liquid that we call mercury, or any other liquid like alcohol also can be used. So because of using liquid, so we call it liquid in glass thermometer. Okay, so in the lab we are quite familiar with this type of thermometer. So it consists of what? The bulb contains fixed mass of liquid such as mercury. When the liquid absorbs heat, it will expand and rise in the capillary tube. So the thermometric property of the liquid used, in this case mercury, is the volume of the mercury that change as temperature change. It will expand uniformly. That's why mercury is the best liquid can be used in the thermometer. Therefore, length of the liquid in capillary tube indicates the magnitude of the temperature. So we just read the upper meniscus of the mercury in the capillary tube in order to determine the temperature of an object. Okay, so let's discuss about some of the application of thermal equilibrium in daily life. So thermal equilibrium causes two objects in thermal context to reach the same temperature. So you can look at the first situation, heating object, like hot oven used for baking. Hot air in oven is in thermal contact with cake batter. Heat from the hot air flows to the cake batter. This causes the cake batter to be heated until it is baked. Okay, and finally when the batter and the temperature in the oven become equal, meaning the cake can be cooked. Okay, so cooling object here, when food kept in the refrigerator, heat from the food flows to the air in the refrigerators until thermal equilibrium occurs. So temperature of the food drop and the food stays fresh for a longer period. Okay, so this one is clinical thermometer is placed under the tongue of a patient. So you can put under armpit also. Now we have so many type of the thermometer, but in the lab normally we use this type like liquid in glass thermometer. So heat from the patient body flows to the thermometer until temperature of the patient and thermometer become the same. The body temperature of the patient can be determined because thermal equilibrium is occurs. Normally when we place the thermometer under the tongue, we need to wait about 1 minute because it needs time for the heat flow between the thermometer and the patient body become equal, so that the temperature will become equal. So the reading of the thermometer is reading of thermal equilibrium achieved. So we call it temperature shown on the thermometer equivalent to temperature of the patient body. Okay, drink are cooled by adding several ice cubes. Ice cube absorb heat from the drink and melt. Melted ice cube absorb heat from the drink until thermal equilibrium is achieved. So you want to cool down your drinks, you can put ice cube. Okay. Okay, now how liquid in glass thermometer can be calibrated? So the process that we want to discuss is calibration. Okay, what is calibration? Okay, the calibration of the thermometer involves following step. Here I will discuss. So what is calibration? It's a process of marking the scale on an unscaled measuring instrument. Any measuring instrument, if you want to mark the scale, the process we call it calibration. So in this case, we want to calibrate a thermometer. Let's say thermometer without scale or unscaled thermometer. Okay, you can refer to activity 4.3 on page 1 to 3 in your textbook. Okay, so in order to calibrate the thermometer, so we are going to use two fixed points. We use ice point and steam point. So in this case, the activity, we use distilled water because pure water or distilled water or pure water, so that we can get ice point 0 degrees Celsius, steam point 100 degrees Celsius. So what we do, the step is quite easy. So we place the thermometer, the unscaled thermometer, into the melting ice. When ice melts, the temperature is 0 degrees Celsius. So what we do, we mark. You can use a marker pen, you can use something like sticker to stick so that you can mark the level for 0 degrees Celsius. And then we take the same temperature, we place into this conical flask. Okay? Okay, in this flask, so that it will measure the steam temperature. Don't put into the water, the bulb. Okay, you just put here at the steam that coming out. Okay, so the temperature shown here, we call it steam point. Again, use a marker pen or any sticker, you can mark there. Okay, so that one is the mark for 100 degrees Celsius. Okay, so this is what we do. Measure the length of the 0 degrees Celsius mark to the 100 degrees Celsius mark and mark as L100. Okay, just now you already mark using the marker pen or sticker just now. So use ruler, you can measure the length between 0 degrees Celsius mark and 100 degrees Celsius mark. Okay, so you can just put it as L100. Okay, then what you do, you want to use the, what you do, you have from 0 to 100 degrees Celsius now is equivalent to 100 degrees Celsius. So you can mark the scale by marking 100 equal division on the thermometer. So now your thermometer will have a scale. So that one we call it calibration. Let's say we want to use the thermometer to determine unknown temperature of a liquid. Let's say we have one liquid, we put the thermometer into the liquid, and you can see the level of mercury column, okay, rise up in the thermometer. Then you mark as theta degrees Celsius. We want to find that theta degrees Celsius, okay? So measure the length from the 0 degrees Celsius mark to the theta degrees Celsius, then you mark as L theta. So this is L theta. Okay, now what we do, we can calculate temperature of the liquid theta by using the formula theta equals to L theta divided by L100 multiplied by 100 degrees Celsius. So actually it's like a proportional formula. Okay, so this is how we determine a temperature of unknown liquid, for example. Before that, we need to calibrate the thermometer. Okay, that one we call it calibration of a liquid in glass thermometer using two fixed points, ice point and steam point. Okay, let's look at one example. Calculate the value of temperature T. So we have here from here to the 0 degrees Celsius is 3.6 centimeter, and then to the unknown temperature T, 9.3 centimeter, and then from here, from the bulb to the 100 degrees Celsius is 13.6 centimeter. So now we want to calculate L theta. L theta is from 0 to T. So meaning 9.3 minus 3.6. So we get 5.7 centimeter. L100 is from 0 to 100. So meaning 13.6 minus 3.6. So we get 10 centimeter. Okay, now we use the formula theta equivalent to L theta divided by L100 times 100 degrees Celsius. So it should be a line here. Okay, now we get 5.7 divided by 10 times 100 degrees Celsius. Thus we get 57 degrees Celsius. So meaning by using these two fixed points, then we can determine the temperature of unknown liquid by calculation using the formula. Okay. Okay, one exercise, try and see. When an uncalibrated mercury in glass thermometer is dipped into melting ice degrees Celsius and length of mercury column is 18 millimeter, when put into steam, the length of mercury column 138 millimeter. What is the length of mercury column when thermometer dipped into hot liquid of 50 degrees Celsius? Okay, now we want to find what is L theta. Okay, so L theta we don't know because not given. So theta is 50 degrees Celsius. L100 equivalent to 138 minus 18. Need to minus because the length of mercury column we measured from the bulb. Okay, that's why I need to minus here. So 120 millimeter. And L0 is given as 18 millimeter. Okay, so we use the formula theta equals to L theta divided by L100 times 100 degrees Celsius. So theta equivalent to 50 equals to L theta divided by 120 times 100. Then we get L theta is 60 millimeter. Remember, L theta is from 0 to theta. Okay, so the question need you to find length of mercury column when thermometer is dipped into hot liquid, meaning the total length from the bulb to 50 degrees Celsius. That's why we need to add again. So length of mercury column at 50 degrees Celsius equals to 60 plus 18 equals to 78 millimeter. Okay. Okay, now liquid in glass thermometer, either we can use mercury or alcohol. So both have its own advantages. So look at the mercury, the freezing point equivalent to negative 39 degrees Celsius, boiling point 357 degrees Celsius. And mercury does not wet the tube. It has a very high, a very low addition to glass. Opaque and easy to read, can easily be seen. The color is opaque. Poisonous, expensive, conduct heat well, is a good heat conductor, respond faster to temperature changes. And this one is alcohol. The freezing point is negative 115 degrees Celsius. Boiling point is 78 degrees Celsius. It wet the tube, colorless, and need to be dyed. You must put color if you use alcohol in the thermometer. Safe liquid, cheap, respond more slowly than mercury. So let's say you want to use the liquid in glass thermometer in the North Pole, which is temperature very, very low, maybe as lower than negative 39 degrees Celsius. If you use mercury, the mercury might freeze. So at the North Pole with temperature is very, very low, so it is suitable to use alcohol in glass thermometer. So that's advantage for alcohol. Okay, the rest you can just look at the advantage of using mercury and advantage of using alcohol. Okay. So to improve sensitivity of thermometer, what is sensitivity? Meaning the thermometer able to responds to a very small change in temperature. You can see the mercury column rises longer for a smaller change in temperature. That one we call it sensitivity of thermometer. So how to make it sensitive? So you can use narrow diameter of capillary tube. Okay, and also we can use a very long stem. Then we have a very narrow capillary tube, longer and narrow capillary tube. Thin glass wall bulb, so can detect heat faster. Okay, thin glass wall bulb and small bulb. So these are the three ways to increase the sensitivity of thermometer. So you must go and read through all about thermometer and liquid in glass thermometer. So that's all for this part 4.1. So you can subscribe, like and tap for more oncoming videos. Do support physics teacher. Thank you.